Hi, everyone. We will continue to discuss uh, what we were discussing in the last session. We'll continue to discuss the building of information system solutions for business problems. Uh, we will take a look at these learning objectives. So we are trying to understand how does building new systems produce organizational change. What are the core activities in the systems development process? What are the principal methodologies for modeling and designing systems? What are the alternative methods for building information systems? What are new approaches for system building in the digital firm era? Now, although we have discussed in the last session a little bit about all of this, but we will try to understand the new systems, the new information systems, how they are built, how they are analyzed, how they are designed and implemented in organizations to handle particularly change. So let's start with the first discussion on the building of new systems. Then we will go and see whether we should make our new system within the organization or we will outsource the new system to outside vendors to design the solutions for us. We should know that systems are a planned organizational change. Structural organizational changes are enabled by information technology. It can come as a way of automation to increase efficiency and to replace manual tasks, or it can be thought of as a rationalization of procedures, wherein we streamline standard operating procedures. Uh, and the rationalization of procedures is often found in programs for making continuous quality improvements. So, total quality management, Six Sigma. These are certain practices which are followed in order to bring about organizational changes to improve quality. Structural organizational changes enabled by IT can also be by way of business process re-engineering, business process redesigning, wherein we take up a typical business process, we analyze it, we simplify it, and redesign the business processes to improve productivity. We also can reorganize the workflows. We can combine many of the steps, make them one step, single step, thereby making the business process a little what simpler. We try to manage and eliminate repetitions so that there's a smooth flow of documents, information, workflow is maintained. We also can think of paradigm shifts. We can rethink nature of business. We can define new business models. We can change the nature of organizations. So this particular slide shows how organizational change carries risks and rewards. The most common forms of organizational change are automation and rationalization. These relatively slow moving and slow changing strategies present modest returns but little risk. Faster and more comprehensive change, uh, like redesign and paradigm shifts. These two particular aspects, they carry high rewards but offer substantial chances of failure of the systems. Business process management, where we are thinking of managing the show through the processes, a variety of tools, methodologies to analyze, design, and optimize processes are available for managers. Business process management is used by firms to manage business processes redesign. Uh, a manager has to follow certain steps of business process management. He identifies processes for change. He analyzes the existing process. So he analyzes the existing process and designs the as-is model. Then he designs the new process, which is the to-be model. So we need to move from the as-is model to the to-be model. Then the to-be model is implemented and continuous measurement of that model is done so that to check whether we are getting the returns from the new model or not. So this shows how as is business process for purchasing a book from a physical bookstore looks like. You have all the processes that a customer has to go through or a clerk has to go through, then again the customer and again the clerk. So purchasing a book from a physical bookstore requires many steps to be performed by both the seller and the customer. This is how the as-is process looks like. The as-is business process looks like. This can be improved by the to-be model. You can see today the complex business process. The complex business process has been simplified, and this business process shows how today you buy books online, wherein between the bookseller and the customer there has been disintermediation, and a book is available to a customer any place, anywhere, anytime, and there is satisfaction by the customer as a use of this business process. He can access online bookstore, search online catalogs. If the book is available, he places the order and pays for it and receives book in by courier. If no, he has to select other online bookstores, again search online catalog, and again go through the process of entering the order, paying the money, and receiving his book by courier. So using internet technology makes it possible to redesign the process for purchasing a book so that it requires fewer steps than was being done as before and consumes fewer resources. Various business process management tools are used to identify and document existing processes so that you can identify inefficiencies and think of removing these inefficiencies to make your business process more vibrant, more smoother. So you can use the BPM tool to create models of improved processes, capture and enforce business goals for performing automating processes. You can integrate existing systems to support process improvements. ERP is such integrated information system solution which integrates existing systems to support process improvements. You can verify that new processes have improved. You can measure the impact of process changes on key business performance indicators as a result of use of these advanced business process management tools. So a systems solution can be developed as a process. It's a series of activities that will take in one or more kinds of inputs to produce an output of value. So the traditional system development process is a series of activities that will go into producing an information system solution to an organizational problem or opportunity. So the steps that a systems designer goes through is that he first analyzes the system, then designs the system, then he writes the programming code, tests the program, converts it, and then does the production and maintenance of the application. This particular flow diagram shows how we build a system by breaking down it into 6 core activities. The first activity is system analysis. The second activity is system design. The third activity, as I told you, is programming. Then we go through the testing of the code, then conversion, then production and maintenance. Basically, the first phase of the system design is that you need to do a system analysis of problems to be solved by the new system. You define the problem and identify the causes. Then you segregate the problem from the system, from the symptoms. You specify solutions at the beginning itself. You present systems proposal report, which identifies and examines alternative solutions to the top management for approval. You, at the system analysis phase, you identify information requirements for your information system. And this particular phase is important because it includes a feasibility study. At the beginning itself, you check whether the new system that is being designed is feasible, correct. Is it feasible, and can it be used to give the maximum returns to the users of the system? So this particular phase includes the feasibility study of various kinds, which we discussed in the earlier session. Is the solution that you are going to design feasible and a good investment? You need to find out an answer to this. Is required technology and the skill available for running the new system? That needs to be answered. So the system analysis phase also requires the manager to establish the information requirements. He needs to answer all these questions. Who needs what information? He has to jot down where, when, and how the information is going to be used. You need to define the objectives of the new or the modified system. You need to detail the functions of the new system which must perform. So faulty requirement analysis is one of the leading causes of systems failure and high systems development costs. So you need to be careful at the beginning of the system design phase. So a thorough and a good system analysis can help you in the long run. Systems design is you need to describe the system specification. You had earlier the information specifications there on hand. Now you have to describe the system specifications that will deliver functions identified during systems analysis. So this second phase should address all managerial, organizational, technological components of the system solution. So here the end user has a role to play in the designing of the alternatives. The end user also come into the picture along with the system designer because he plays a role wherein he is the one who provides the user information requirements, because that will drive the system building. Users, the end users must have sufficient control over the design process to ensure the system that is being designed reflects their business priorities and information needs. So insufficient user involvement in design efforts can be a root cause or is a major cause of system failure. Design specification, these are the details that you have to keep track of while developing a new information systems or while modifying an existing system. You need to first identify what are the requirements for the output, for the input, for the processing, for the interfacing, for the database design, for the procedures to be laid down, the controls that has to be incorporated, the security constraints that has to be incorporated, that conversion that has to be done, that training that you need to provide, the organizational changes that will be brought about, and finally the documentation of each and every step of the systems development process. So basically, this is what you need to have with you in order to come up with a new solution or to modify a new system to existing system. So the system development process, apart from the system analysis and system design, it also includes the steps of programming, testing, converting, and then implementing. So programming is nothing but the system specifications from design stage are translated into a software program code. So you can use any of the software programming languages to come up with the system specifications from the design stage, and you need to translate it into the programming language that you are using, the programming language code that you are using. Then you need to test the system. It ensures testing ensures system produces the right results. So you are involved in various kinds of testing. You can either go for unit testing, wherein you test each program in the system separately. You can do a system testing where the test functioning of the system as a whole is carried out. You can do acceptance testing, which makes sure system is ready to be used in production setting. Then you need to have a test plan. All preparations for the series of tests need to be jotted down in the test plan. A simple test plan to test a record change is shown in the slide. When developing a test plan, it is imperative to include the various conditions to be tested, the requirements for each condition tested, and the expected results. So test plans require input from both end users and information systems specialists. So the system development process, which includes the phase of conversion, it is nothing but the process of changing from old system to the new system. It basically has four main strategies that you need to follow for converting the old into the new. You need to have a parallel strategy if you have to expedite the implementation of the new system, and direct cutover strategies. You can follow a pilot study strategy or a phased approach development. So conversion is a specialized activity wherein it requires end user training. Finalization of detailed documentation also needs to be done here because the documentation shows how system works from technical and end user standpoint. Then after this phase of conversion, we come to the phase of production and maintenance. The new system is to be produced and maintained so that it gives the return on investments for the new system. So in this phase, the system is reviewed to determine if revisions are needed. This may include a post-implementation audit document, and maintenance is a Herculean task for all managers because it includes changes in hardware, software, documentation, or procedures to a production system to correct errors. You need to meet new requirements or improve processing efficiency. 20% of the time you'll be involved in debugging and emergency work. 20% of the time you'll be involved in changes to hardware, software, data, and reporting. But you can see 60% of the work in maintenance goes in for user enhancements, improving documentation, recoding for greater processing efficiency. So to sum up, a summary of the systems development activities, what goes on in each of these phases that we discussed just now. In the system analysis phase, you need to identify the problem, you need to specify the solution. But while identifying the problem or the problems or the opportunities, you need to segregate the problem from the symptoms. The problem has to be attacked separately, the symptoms need to be addressed separately to arrive at a particular solution. But what is the end result of this phase? You establish the information requirements for the new system. Then you go through the second phase of the systems development lifecycle process, wherein you create design specifications. Then comes the third phase where you are involved in programming in a particular programming language. You translate the design specifications into code. Then once the code is ready, you need to do a testing of the entire application by way of unit testing, systems testing, and acceptance testing. Then the old system is converted into the new system. It can either be a planned conversion, or you can also have a phased manner conversion, or and you need to prepare the documentation for the new system design. You need to train the users and the technical staff to handle the new system. Then the final phase of the systems development process is that you are involved in production and maintenance of the new system. You need to operate the system, you need to evaluate the system, and you need to modify the old into the new. So there are various methodologies for modeling and designing the new systems. Most prominent methodologies for modeling and designing systems are structured methodologies, but you can also have an object-oriented development process methodology. Structured methodologies, they include structured, process-oriented methods. So in the structured methodologies, you use structured methodologies, that is, techniques are step-by-step and progressive. And they are the structured methodology has typical characteristics of process orientation. That means it focuses on modeling processes or actions that manipulate data. You can separate, you have to separately handle the data from the processes in the structured methodologies. So to come up with a structured methodology, you can use the data flow diagram as a primary tool for representing the system's components, component processes, and flow of data between them. Data flow diagrams can also offer you the logical graphic model of information flow. DFDs are nothing but high-level and lower-level diagrams that can be used to break processes down into successive layers of detail. So it is not just the data flow diagram which you need to devise, rather you can also devise the data dictionary. Data dictionary defines the contents of the data flows and the data stores. You need to also jot down the process specifications. So initially we had the information specifications, and then we had the system specifications. You can also have the process specifications, which describe the transformation occurring within lowest level of data flow diagrams. You can also come up with a structured chart. These are some of the tools basically to come up with a structured model of system design. So structured charts are nothing but top-down charts. So in each level of design, the relations to other levels, and they place an overall design structure. This shows the data flow diagram for a mail-in university registration system. The system has three processes. You verify availability, you enroll the student, and you confirm registration. But if you take a look, the name and content of each of the data flows appear adjacent to each row. There is one external entity in this system, the student. There are two data stores, the student master file and the course file. A high-level structure chart for a payroll system shows this. You can prepare a structure chart for a payroll system of your organization like this. This structure chart shows the highest or most abstract level of design for a payroll system of an organization, providing an overview of the entire system. Object-oriented development methodologies are also followed by information systems designers to design the new systems. Object is nothing but a basic unit of system analysis and design. Object basically combines data and the process that operate on those data. Data encapsulation is done wherein the data encapsulated in object can be accessed and modified only by operations or methods associated with that object. Object-oriented modeling based on concepts of class and inheritance is also followed, wherein objects belong to a certain class and have features of that class. They may inherit structures and behaviors of a more general ancestor class. So this shows class and inheritance of an object-oriented methodology. This figure basically illustrates how classes inherit the common features of their superclass. You see the classes like salaried, hourly, and temporary. They acquire or inherit the features of their superclass, which is the employee. Okay, typical to a particular employee, he is salaried and he gets a wage and what kind of appointment he has with the organization. So object-oriented development of systems can be more iterative and incremental than the traditional structured development. In the object-oriented development methodology, system analysis is nothing but the interaction between system and users analyzed to identify the object, and the design phase describes how objects will behave and interact, grouped into classes, subclasses, and hierarchies. And the implementation phase talks about some classes which can be reused from the existing library of classes. Others may be created or inherited. Because objects are reusable, object-oriented development can potentially reduce time and cost of development of a new system. Apart from the structured methodology and the object-oriented methodology, in order to expedite the development of a new system, computer-aided software engineering is also available to come up with new softwares or new systems. CASE is nothing but a set of software tools to automate development and reduce repetitive work, which may include graphics facilities for producing charts and diagrams, screen and report generators, reporting facilities, analysis and checking tools, data dictionaries, code and documentation generators. CASE basically supports iterative design by automating revisions and changes and providing prototyping facilities. So you can quickly come up with a new system if you follow computer-aided software engineering tools for designing new systems. And CASE basically requires organizational discipline to be used effectively. Apart from the structured methodologies, the object-oriented methodologies, and the computer-aided software engineering methodology, there are also alternative systems building methods. What are those alternative systems building methods? The traditional system lifecycle is one of the method to come up with a new system. Prototyping is another, wherein we come up with a small prototype of the actual system. End user development can happen to come up with a new system. Application software packages today are widely used to develop quickly information system. Last or not the least, you can outsource the development of the system either to outside parties, or if you have a strong set of highly experienced and technically sound information technology specialist, you can also outsource to internal stakeholders for the development of the system. So the traditional systems lifecycle is the oldest method for building information systems. It can take a phased approach wherein development is divided into formal stages. The waterfall approach is one of the most useful example of this kind of systems development, wherein in this approach, one stage finishes before the next stage begins. There is formal division of labor between end users and information system specialists. Uh, Traditional systems lifecycle emphasizes formal specifications and paperwork. This kind of life cycle for development is still used for building large complex systems. These traditional systems lifecycle procedures, when followed for development of systems, can be costly, time consuming, and inflexible. So people look for various other alternative system building methods, such as prototyping. Prototyping can expedite the development of a new system by building experimental system rapidly and inexpensively for end users to evaluate. A prototype is nothing but a working model, but or a preliminary version of the information system. The steps that you need to follow in prototyping are: you need to identify first the user requirements. You develop a small prototype, initial prototype. Then you use the prototype with the demo data. You can use the prototype. You can revise and enhance the prototype before the new system can be implemented. So this shows the prototyping process. The process of developing a prototype can be broken down into four steps. Because a prototype can be developed quickly and inexpensively, system builders can go through several iterations, repeating step 3 and 4 that you see, to refine and enhance the prototype before arriving at the final operational one. There are many advantages and disadvantages to the alternative systems building methods. In the prototyping, the advantages are: a prototyping method is useful if some uncertainty in requirements or design solutions you have. Often, it is often used for end user interface design, and more likely, it is designed to fulfill end user requirements. Uh, Disadvantages of prototyping are: it may gloss over essential steps, it may not accommodate large quantities of data or large number of users. End user development is another alternative systems building method. It allows end users to develop simple information systems with little or no help from technical specialists. It reduces time and steps required to produce finished application. And tools for end user development may include user-friendly query languages like SQL and reporting tools, and personal computer software tools. So the advantages of end user development are that more rapid completion of the projects can happen, high level of user involvement and satisfaction can take place. The disadvantages are that the end user development, uh, it is not basically designed for processing intensive applications. It is inadequate because there is inadequate management and control, testing and documentation, and there is a loss of control over data. So you need to manage the end user development, which requires cost justification of end user systems projects. You need to establish hardware, software, and quality standards. Application software packages can save time and money. Many of these application software packages, they offer customization features. Softwares can be modified to meet unique requirements without destroying integrity of packaged software. Evaluation criteria for systems analysis using the application software packages include functions provided by the package, flexibility, user friendliness, hardware and software resources, database requirements, installation and maintenance efforts, documentation, vendor quality, and cost. So, application software packages, in order to come up with a new solution, you need to have a request for proposal wherein you detail the list of questions to be submitted to package software vendors. RFP can be used to evaluate alternative software packages also. So, as I told you, a new system can either be made in-house or it can be outsourced. Outsourcing of the development of information systems uh, is growing at a very fast rate. Companies basically use a combination of employees, local vendors, and offshore providers for their information system services. In this way, they can create the optimal combination to take advantage of best price and talent. Although offshore outsourcing dominates today, domestic outsourcing is also growing at a very fast pace. The demand for outsourcing services is driven notably by advances in cloud computing and the provision of business processes as a service. Outsourcing is fundamentally, you'll see, is a make or buy decision. There are several types of outsourcing of the applications. You can have the cloud and the SaaS providers, software as a service, wherein you can pay to a agency for use of software and computer hardware provided by the agency or the vendors. You can also have external vendors to whom you outsource the design of the solutions. You can hire to design, create software for your organization. It can either be offsource outsourcing or it can be domestic outsourcing. Although earlier it was mainly offshore outsourcing, but today domestic outsourcing is growing at a very fast rate, wherein the activities are driven by firms needed for which need additional skills, resources, and assets. When you need additional skills, resources, assets, you actually outsource it to a domestic firm. When you are driven by cost saving, you think of offshore outsourcing. So outsourcing basically can have its own advantages and disadvantages. Outsourcing allows organizations flexibility in IT needs, but it can have hidden costs. For example, identifying and selecting vendor can be costly. Transitioning to a new vendor can also be a costly affair. Opening up proprietary business processes to third party can be a disadvantage. The total cost of outsourcing is shown to you. If a firm spends $10 million on outsourcing contracts, that company will actually spend 15.2% in extra costs, even under the best case scenario. In the worst case scenario, where there is a dramatic drop in productivity along with exceptionally high transition and layoff costs, a firm can expect to pay up to 57% in extra costs on top of the $10 million outlay for an offshore contract. RAD, this is another new approach for system building because people don't have the time today. They use a rapid application development methodology wherein you follow the process of creating workable systems in a very short period of time. This RAD development type of development utilizes techniques such as visual programming and other tools for building graphical user interfaces. Iterative prototyping of key system elements can take place. Automation of program code generation is done, and close teamwork among end users and information system specialists can give good results for a rapid RAD kind of development of solutions. Apart from the RAD, you also have something called as the JAD, the Joint Application Design, which is used to accelerate the generation of information requirements and to develop initial systems design. It brings end users and information system specialists together in interactive sessions to discuss systems design. JAD can significantly speed up design phase and involve users at intense level. You also have a new approach for system building, which is called as agile development, which focuses on rapid delivery of working software by breaking large project into several small sub-projects. Sub-projects are subsets of the larger projects. They are treated as separate complete projects, completed in short periods of time using iteration and continuous feedback. Agile development emphasizes face-to-face communication over written documents, allowing collaboration and faster decision-making. You can also have a component-based development wherein groups of objects that provide software for common functions like online ordering and can be combined to create large-scale business applications. You can also have web services wherein reusable software components that use extended ML, extensible markup language, and open internet standards, which are platform independent. You can enable applications to communicate with no custom programming required to share data and services. You can engage with other web services for more complex transactions. Using platform and device independent standards, web services can result in significant cost savings and opportunities for collaboration with other companies. Application development for the digital firm can happen because of mobile application development, mobile websites, mobile web apps, native apps. Mobile application development has special requirements for mobile platforms, smaller screens, keyboards, the multi-touch gestures, saving resources of memory and processing is a must for mobile application development. You also need to come up with a responsive web design for a mobile application development, wherein websites are programmed so that layouts change automatically according to the user's computing device. So the challenge of mobile application development is that you need to have answers to these questions. What management, organization, technology issues need to be addressed when building mobile application? You have to find an answer to this. How does user requirement definition for mobile applications differ from that in the traditional system analysis? You need to find out. And finally, outsourcing can be of two types, as I told you, insourcing or outsourcing. Projects may be insourced, they can be developed in-house, or the development can happen with outside vendors in the play. So insourcing uses the professional expertise within an organization to develop and maintain its information technology systems, whereas outsourcing is an arrangement by which one organization provides a service or services for another organization that chooses not to perform them in-house. So various factors drive outsourcing growth, which may include core competencies, financial savings, rapid growth, the internet, and globalization. These are some of the factors which are responsible for the growth of outsourcing. Companies want to focus on their core competencies. When they focus on their core competencies, the other processes are outsourced to be taken care of outside vendors. When you think of financial savings, you think of outsourcing. When you want rapid growth, you hire consultants who can contribute to the system that you want to implement. And last but not the least, outsourcing has been today done very widely because of the ease at which you can hire experts by using the internet, and as a result of globalization, you can take the help of vendors and consultants who are there on the cooperative network worldwide. This figure shows the locations of outsourcing and the customer control. You can see that from onshore we move to the near shore, and from the near shore we can offshore. So outsourcing can provide many benefits to organizations, like it can increase quality and efficiency of business processes. It can reduce operating expenses for headcount and exposure to risk for large capital investments. Outsourcing can provide benefits like access to outsourcing service providers, expertise, economies of scale, best practices, and advanced technologies. It can also provide increased flexibility for faster response to market changes and less time to market for new products or services. Along with the many advantages, outsourcing can also provide or throw many challenges, which may include the length of contract, difficulties in getting out of a contract, problems in forcing future needs, problems in reforming an internal IT department after the contract is finished, threat to competitive advantage, loss of confidentiality. Okay, so with this, we come to the end of today's session. All of you should know, outsourcing basically, you have to, whenever you think of outsourcing the systems development, you have to think of four things. The first one is the decision to outsource. Second is the contract. The third is the management of the relationship between the firm and the vendor. And the fourth one is the most important one. Risk assessment and risk mitigation has to be done. So these are the four aspects that when you think of outsourcing the systems development, you need to keep in mind and going for outsourcing the development of the new system. With this, we come to the end of today's session. Thank you.